So when I look at problem 3, I see that this is an isosceles triangle. And I know that because it shows me that these two angles are congruent to each other. So the converse of the base angles conjecture would then say this triangle has to be isosceles. So the fastest one that I can find is this distance L, which has to be 8 feet because those two legs have to be congruent to each other. To find K and J, I know they're congruent to each other. Well, putting the two together to find those, I would take 180 minus the 140 to see what I have to split between K and J. Since they're congruent though, once I do that, I can just divide this by 2. So 180 minus 140 is 40, divided by 2 is 20 degrees. Again, this one was typed. You have these angle measures for a triangle. Is it possible that it's isosceles? Well, if it's isosceles, then the isosceles triangle conjecture says that I would either need two 65-degree angles and a 40-degree angle, or two 40-degree angles and a 65-degree angle. The triangle sum conjecture says that if I add those three angle measures together, I have to get 180 degrees. So I need to reference both of those conjectures so that, both of those conjectures as far as my explanation goes. So the isosceles triangle conjecture says the base angles of an isosceles triangle are congruent. So well, this is what I said. It would mean the angle measures would either be 65, 65, 40 or 40, 40, 65. The triangle sum conjecture says the three angle measures must add up to 180 degrees, but that would not work in either of these cases. So the 65, 65, 40 is going to be 170. 40, 40, 65 is going to be 145 degrees.